Okay, ladies and gentlemen, it's a pleasure to have you with us today for the fourth International Urban Cooperation Program webinar. I think we can make a start now. My name is Sean Carroll. I'm part of the IUC Coordination Unit. I'm joined today by my colleagues Serene and Barbara, who will be today's moderators, and Serene will also be dealing with the technical issues of the webinar. Thank you very much for joining us for what is sure to be a very interesting discussion. Today's topic is, of course, choosing locally appropriate solutions for wastewater management. This is a topic that I personally am very much looking forward to hearing more about and hearing from our speakers. We, of course, have a very experienced program with speakers from Aarhus, Nagpur, Hamburg, and, of course, Japan. I think that wastewater is increasingly becoming a challenge as urban populations grow. And it really is a challenge that requires government authorities and public utilities to become more creative and innovative in their approach to wastewater management. I mean, one of the challenges is that they need to develop solutions that are fit for purpose, that are ecologically sound, and that meet the needs of residents and other stakeholders. What we're really trying to do is create a mind shift away from viewing water as waste to be dealt with and instead seeing it as a valuable resource. So I'm sure that our speakers will have great insights to share with us today. As I mentioned, this is indeed the fourth of the IUC webinar series. I'd actually like to give you a very brief introduction to what the IUC is. Just at the outset. So the IUC is the International Urban Cooperation Program. It's funded by the European Union, and it's basically a way for cities and regions within the European Union to link up with other cities and regions from regions around the world to share solutions to common sustainable development problems. So it's really a way for the European Union to foster sustainable urban development both in Europe and further abroad. And it's also a way for the EU to make a tangible and really meaningful contribution to international agreements such as the Paris Agreement, but also the Sustainable Development Goals, which is of course run by the UN and covers a huge range and breadth of topics related to sustainable development, and of course the new European Urban Agenda, which is 12 priority themes set by the European Union. In terms of the themes that are covered by the IUC, it's very broad indeed. It ranges from mobility and transport to climate adaptation and mitigation, and even topics such as poverty and social inclusion. So when a pairing is created, the cities agree to focus, or indeed the regions agree to focus on a specific area of sustainable development, and they work on this for at least 18 months, and they agree to create what's called a local action plan, which basically sets out how they're going to mutually tackle this problem. There are three pillars to the IUC, so it's made up of three specific sections. The first, as I mentioned, is city-to-city cooperation, so pairing an EU city with a city from another international region to work on sustainable urban development. The second pillar is the Global Covenant of Mayors initiative. So the IUC is supporting the rollout of the Covenant of Mayors in regions around the world. For those not familiar with the Covenant of Mayors, it's a movement of cities. It supports cities to become more ambitious in their climate mitigation and climate adaptation activities. And then thirdly, it focuses on region-to-region cooperation. So this is going beyond the city level to the regional level and encourages regions to work together on tackling sustainable development challenges, and particularly in becoming more innovative. And this is specifically between European Union regions and regions in Latin America. There are currently 66 pairings established through the IUC. More will be coming online very soon. You can see from the cities listed here in this slide that we have, it's truly an international program with regions from Asia, Latin America, North America, and there's also a specific focus on Japan and India as well. There are 18 pairings established in component 3, so the regional pairings. You can see that it really covers the breadth of Latin America, Argentina, Brazil, Chile, Colombia, Mexico, and Peru. I would strongly encourage you to go to the IUC website. It's www.iuc.eu. You can see a full list of city pairings and regional pairings there, and you can find out more about them. And if you have any questions, or if you'd like to address us directly, you can reach us at coordination-unit@iuc-europe.eu. Well, thank you very much for your attention, and I really look forward to getting this webinar underway and to hearing more about the topic at hand. So I'd like to hand over now to my colleague Serene, who will tell us more about today's webinar.
Thank you very much, Sean, for this introduction and the general overview of the IUC. So welcome everyone again from our side as well. As mentioned, if you're having any technical issues, please let us know. You are all muted. If you have any questions, write them in the chat and we will be sharing them then. We will have 2 opportunities for questions, and we will be collecting the questions throughout the webinar. So please just write them in the Q&A or just to the general chat, and we will address them to the relative speakers when it is time. So please also make sure to say who your question is addressed to. Now I will hand over to Barbara Anton from the IUC Coordination Unit to continue the webinar.
Thank you, Serene, and happy to kick it off now. So we will be starting, or we'll be talking about wastewater here and provide a snapshot on a number of different aspects that will of managing wastewater, and this will be illustrated by practical examples. We really hope that you will learn something new on approaches and solutions which could be relevant in your own city or in your other context of work, and hopefully you will find some fresh inspiration on how to deal with wastewater issues in your city in the future. The webinar will, for one, include 2 local examples, one from Europe and one from Asia. In Aarhus in Denmark, the municipality is currently planning for a high-tech facility that fulfills 2 functions at the same time. It will treat the city's wastewater, but also recover valuable resources. In Nagpur in India, the municipality applies natural treatment processes and utilizes the reclaimed water for irrigating urban green spaces using a new methodology. After we have heard from these 2 examples, we will dedicate a few minutes to answering some first questions, if some have come up at this point. The third case, then from Japan, is about awareness raising and public involvement in the field of wastewater management, so a different perspective. Togo Ushida, a colleague of the IUC program in Japan, will tell us how the country has rallied public support to sustain its wastewater infrastructure via developing an interactive manhole-card game. Sounds really exciting for the citizens. So here it's actually national government that has taken the initiative, although the approach can certainly also be replicated at local scale. Before looking at these local examples, we are having an introduction from Dr. Claudia Wendland, who is Senior Water and Sanitation Specialist at Hamburg Wasser, the public utility of the 2nd biggest city in Germany, and she will set the scene by giving us a broader overview. So, Claudia, are you ready to go? Please say also a few words about yourself, and I guess you will also say a few words about Hamburg Wasser while going along.
Yeah, thank you very much, Barbara. Good morning or good afternoon or from wherever you are listening. Yeah, my name is Claudia Wendland. I'm working since more than 20 years in the water and sanitation field, and since a few time I work for Hamburg Wasser. Hamburg Wasser is the 2nd biggest water and wastewater utility in Germany, based in the north of Germany. Yeah, I'm supposed to thank you first for the invitation to give a short introduction. I'm supposed to give a a little bit of background, and I hope some interesting insights for you, which are important to choose locally appropriate solutions for wastewater management. For the background, you can see the first slide, which is of course starting with the Agenda 2030 that I guess you all know very well, with the 17 global goals set by the UN. Just maybe to mention that it's really a transforming agenda. It's meant to make the world really sustainable, and it refers to not only the global south as the MDG before, but also to the so-called developed countries. So it refers also to, for example, Europe. Maybe not so well known to you is the new urban agenda, which was adopted 1 year later in 2016. But it might, if you have a look at it, it gives a nice toolbox also how to make cities really sustainable, and how urban planning can be fostered, and water and wastewater plays a major role there. That can give you also a good background why water and wastewater management is a key in city planning. The document is available in a number of UN languages if you want to have a look at it. On the next slide, I took the picture, which I really like very much. It is made from the Sustainable Sanitation Alliance, and puts sanitation at the core of the Agenda 2030. And here with sanitation, it is meant the whole sanitation chain. So that means from the toilet, from the interface to the customer, until the wastewater management, disposal, and or reuse. So sanitation covers, of course, wastewater treatment as well. And why it's important to look at the whole sanitation chain also in wastewater treatment is, if you think of new concepts or innovations, then of course the interface to the customer and to the population is very important. So if you think of, for example, source-separated concepts, it's important to have a look also at the toilet, and either you choose standard, so-called standard flush toilet system, but there are also other options like vacuum toilets, separating toilets, and they needed, and also the piping systems behind plays a role. So that's all important. So that's why important to look at the whole sanitation chain. The other SDGs, that is SDG 6, of course, water and sanitation and wastewater treatment is under SDG 6, but what is important here to mention, maybe for you, is the link to SDG 11, to sustainable cities and communities, because if there's no proper wastewater treatment and management, there's no need to think about developing cities further, because it won't work. And that is very important. Also to mention climate action, SDG 13 is wastewater treatment, especially stormwater management, can be a very powerful tool also to mitigate and adapt and do climate adaptation measures at local level, at local urban level. Maybe also mentioning here shortly the goal 17, the partnership goal. There's an interesting new program coming up from German ministry and also at EU level now. That is a partnership program for utilities. So it is a peer-to-peer program for partnerships between European or German utilities with international utilities. So if you're more interested in that, you can also contact me. And if we look at the next slide, at the SDG 6 specifically, it's not only one target, it covers 6 targets. And interesting that sanitation and wastewater treatment has 2 targets. So it is 6.2 and 6.3. And 6.3 explicitly mentions water quality and wastewater treatment by 2030 to improve water quality by reducing pollution and halving the proportion of untreated wastewater and substantially increasing recycling and safe reuse. So safe reuse is explicitly mentioned, and untreated wastewater, probably you know the figure that more than 80% worldwide of the wastewater is not treated so far. So that is a clear target to deal with. And yeah, I took this picture because I think the water operators and the utilities, especially in the urban areas, are at the core of efficient wastewater management as well. So they are central to achieve also the goal 6.3. That's why they are here, put in the middle. What are guiding principles from my side when it comes to wastewater management? Now I come a little bit with the experience we made also at Hamburg Wasser, and two of main guiding principles are the polluters pay principle and thinking in cycles. So what does that mean? Polluters pay principle, I guess you all know that. What does that mean? For example, if you talk about centralized systems, it's even important also in our case where we have a big centralized system in Hamburg. Very important is a look at the indirect discharges, because we might have lots of troubles in the wastewater treatment plant, and it's very important to have a consistent monitoring of the indirect discharges and look where the biggest polluters come from. Very important is also for individuals to run information campaigns, for example, to reduce the medical residues. We found lots of medical residues, and we know that many households throw their leftover medicine, for example, in the toilets. There's also the issue of artificial sweeteners that are not degraded in the wastewater treatment. So that is another aspect to run this type of information campaigns, which are important to reduce the load anyway in the wastewater. And then, of course, to look also at particular sources for pollution, to look, for example, at clinical wastewater, because we know from wastewater from hospitals discharge lots of, for example, antibiotics and other medical residues. And if they can be treated at source, it's much more efficient to do that before discharging or before treating it further or even reusing it. And that's why we, even in the centralized systems, we look at these sources and these polluters. When it comes to the other principle, thinking in cycles, at urban level, that means first, very important to look at the stormwater management, to separate the stormwater from the other wastewater streams, because stormwater makes the sewage much bigger, and it's much easier to treat the stormwater, to collect and treat the stormwater locally. Even it does not need to be treated if it's just from houses, for example. So integrated stormwater management is a very important feature and has to be dealt with together with the city, authority that is usually in charge, and with the utility. So, for example, in Hamburg, we run programs to promote more and more local stormwater treatment at individual basis, at commercial basis, and that is very important also to, as I said before, to adapt and to improve the local climate in cities. When stormwater can be evaporated, for example, locally, it has a very big impact to improve the local city climate. And then treatment at source, that is what I already mentioned. In our case, I give you an example where in a demonstration project in the city, black water and grey water is separated, and energy produced out of it, biogas in terms of, and then heat and electricity. Also from the sludge, from the sewage sludge, biogas can be generated. We also use, for example, in Hamburg, thermal energy from water. In one case, we have an interesting example with the municipal cooperation with the municipal zoo here, and they use for the Arctic cage. They need a lot of cold, of course, for the polar bears, and we use the cold from the groundwater with exchangers. Can be used there, and also for the heat side that is possible. And Hamburg Wasser is very proud of having a phosphorus recycling plant now, but unfortunately that is not directly at source, but that is phosphorus recovery from end of the pipe, because we have this centralized wastewater treatment plant, we have a sludge treatment, energy recovery, and then incinerator, and we take out the phosphorus in terms of phosphorus acid out of the ashes. Maybe I just show you one example. I mentioned the Hamburg water cycle, and then if you're more interested in the energy part, I have some backup slides if you're interested. The Hamburg water cycle is a very interesting demonstration project. There's also a website about it, and it's now just almost finished in construction. It's in the middle of the city of Hamburg, a residential area which was an old military area, and now for 800 households this water cycle has been realized, and the rainwater is anyway treated separately. It's decentralized managed. It's collected in a small pond and evaporated, as you can see on the. Can you see it? I have to go to the next slide. Sorry. Now here you can see the next slide. The rainwater is collected in the pond and evaporated locally. As you can see, the grey water is the water that's coming from the household, from washing machine, from dishwashing, hand washing, and so on, but not the toilet. That is the black water, and the grey water is separately collected and treated locally in this small residential area. The black water, the water from the toilet, is collected in vacuum toilets, so all the households have installed vacuum toilets so that the black water is a little bit thicker, so to say. It has a higher COD content, and it's better for digestion and easier. So it's co-digested with organic waste in the digester locally, and heat and power is in a combined unit generated locally. So that's now being realized. The digester is now started to work, and we're very happy that it works now. We had a lot of public engagement, so the population is very positive about the project, which is very important to have the customers on board that are promoting it, of course, and like it and accept it. Yeah, so I think that was for my introduction. Thank you very much. And if you need more information, please contact me.
Okay, thanks a lot, Claudia. This has been very interesting and gives us the broader picture of where what wastewater management fits in. I've also already learned something new because I wasn't aware at all that artificial sweeteners would also be a problem in the wastewater system. Interesting. We are now moving on to the first case presentation, which is coming from Aarhus. I understand that the municipality really has huge plans for a new wastewater plant that is to become the most resource-efficient wastewater plant in the world. Is that true? But I'm handing over to Gitte and Maiken, who will certainly explain.
Hello, everybody. First of all, we want to thank you for inviting us to give a presentation on this webinar. My name is Gitte Normann. I'm the head of the groundwater and wastewater section in Aarhus Municipality. And with me, I have my colleague from our utility, Aarhus Water, Mrs. Maiken Bjørn Andersen, who will take over in this presentation a little later. We are very fond to present the city of Aarhus and some of the high-tech solutions that we have taken into use in our effort to implement the wastewater in a circular bioeconomy. We will also present for you how we, with a new way of thinking, has transformed wastewater from an environmental problem to a resource which can be used as a benefit for the whole city. Here on the front page of our presentation, you can see a part of the old city, which hopefully can give you a brief impression of who we are. A little about the agenda for this presentation. I'll tell a little about the city of Aarhus and our wastewater planning in a long-term perspective. And then Maiken will take over and tell more about our wastewater treatment plant, which we have transformed to an energy-producing plant. Aarhus, the city of Aarhus, it's the second largest city in Denmark, and it's located at the red spot you can see on the slide at the east coast of the peninsula, which is called Jutland. Aarhus is a very old city. It was founded by the Vikings, actually, more than 1,200 years ago. And today it has developed to be one of the most important cultural and economic cores of the region. And some facts about the municipality you can also see here on the slides. The area is 470 square kilometers and the urban area is 120 square kilometers. We have a population in the municipality at about 350,000 inhabitants, and the inner urban area, there is 270,000 citizens. That makes a density for the whole municipality for about 750 persons per square kilometers. We are growing very fastly in a Danish context, and we have an expected growth, which we have actually also seen for the last year, of 5,000 new persons who moves to the city each year, and we are developing 2,000 new workplaces each year. We are surrounded by water, and the water has always been an essential part of our life, whether it comes to our coastlines, our lakes and nature, our ground and drinking water, or our harbor, which is the largest container port in Denmark. The water is therefore also an important focus point when it comes to planning and developing the city for our future generations. The city of Aarhus has guidelines to secure a healthy city, while we are growing and expanding as fast as we are. It's very important for us to secure that we have clean and cheap drinking water for everyone, that we have clean water in the streams, our lakes, and Aarhus Bay, for example, for water sports and fishing and so on, that we have good access to nature areas for all our citizens, for example, for recreation. And we also have a CO2 policy which says that we have to be CO2 neutral in 2030. And we are also developing the city so it's adapted to the climate changes where we expect more water in the future. And now a little about our wastewater planning. The first sewer system in Aarhus were built around 1900. And at this time, the primary purpose was to get the wastewater away from the surface for hygienic reasons and to avoid illness. In 1971, we had the first Danish Ministry of Environment, and in 1973, the first Danish Law of Environment Protection was implemented. According to the environmental law, the municipalities must prepare wastewater plans to manage the development of sewer systems, the treatment of wastewater, and finally, but not least, to create the basis to charge the necessary tariffs from the consumers. The tariffs, I think, is one of the main points in how we succeed in financing and building up the sewer systems and the wastewater treatment plants that we see today, where we have around 120 square kilometers of public sewer area. That's 100% of the urban area and around a fourth of the total municipal area. We also have a little less than 3,000 kilometers of sewer lines. And when you look at the map at the right side of the slide, you can see we have three different kinds of sewer systems. The red areas are combined sewer systems. It's the eldest sewer systems that we have in the city. They are more than 50 years old. Then the blue areas is our separated sewer systems. All the new sewer systems we are making are always separated system, where we have the sewage in one line and the rainwater in another line. And then we have the green areas where there is only a sewage line and the rainwater is treated locally. And we have a long-term strategy for separating all our combined sewer systems. There's different purposes for this separating strategy. One of the purposes is to eliminate the overflow of wastewater to houses and terrain when it's raining. We have had some severe accidents with overflow of thin sewage into people's houses, and of course that's bad. And then when we separate the sewer system, it's also is giving us a reduced load on our wastewater treatment plants. We have the possibility to delay the rainwater in basin or lakes where it's purified and hold back, and then we reduce the risk of flooding in the city. And at least but not last, we are using the rainwater for recreational purposes. We also have a centralization strategy for our treatment plants. For about 7-8 years ago, we had actually 7 treatment plants, and today we have only 4 left. And we are going to close down even 2 more, then we only have 2 central treatment plants left. With this strategy, we have an estimated saving in operating expenses of 29 million Danish kroner or 3.5 million euros per year. So it's a lot of money we can save. And there's also a lot of other benefits by centralizing our sewage plants. We have better water treatment. We can use the best applied technology. We have better quality of water in our recipients, and we actually also get some new urban spaces where we can do urban development. Today we have 4 plants left. You can see them on the left side. One is at the north. It's called EO. It has a red spot here. And then we have Marselisborg, which is in the middle of the municipality at the harbor side. And Marselisborg is where we're going to build a new plant, as Serene just mentioned. Today we also have 2 plants, one called Åby, one called Viby, which is going to be locked down and demolished, and all the wastewater is going to be cut off to the new Marselisborg treatment plant. And now I have given you a short impression of who we are in the city of Aarhus, and I will give the word to Maiken, who is working at our utility Aarhus Water, and she will tell you more about how we are running the plants and our goals for the new plant.
Hello, my name is Maiken Bjørn Andersen, and I'm a chemical engineer and project manager in Aarhus Water, which is the water utility in the city of Aarhus. So We have 4 wastewater treatment plants, as Gitte just said, and this is a picture of the biggest one. The capacity is 220,000 person equivalents, and you can see on the picture that on the left side there's an inlet pumping station, and then the outlet pump is near the sand filters in the right side of the picture. The plant is an activated sludge treatment plant, which means that we remove nutrients biologically. So on this graph, you can see that we have actually produced energy since 1990. We produced electricity since 1990. And since 2006, we made major optimization actions to improve the water treatment, to reduce energy consumption, and to increase energy production. As you see on the graph, the plant became net energy positive in 2011. So the main activities that we have done from 2006 to 2017 has been automation of N removal, implementation of Animox bacteria, replacement of final dewatering unit, and a more efficient blower. And I have chosen to focus on process optimization and Animox bacteria, as these are the newer technologies. To optimize the nutrient removal processes, we installed online monitoring of ammonia, nitrate, and phosphorus. The blower was controlled according to ammonia load, and the lengths of nitrification and denitrification phases were adjusted. A new return sludge and excess sludge control was implemented. This was a relatively small investment, as very little new equipment was installed, and most of the investment was actually man hours and developing new strategies for control. So a big thing that we installed was the side stream Animox treatment. We implemented that in 2014, and this should reduce the ammonia load on the process in the mainstream. The deammonification pathway is more energy efficient than traditional nitrification and denitrification because less energy is required. So we don't have to blow so much air into the side stream. And also no carbon is required in this process, which opens up for the possibility of harvesting more COD in the primary treatment, which also is leading to increased biogas production and therefore increased electricity production. So a side effect that we didn't see from this side stream implementation was that we actually think that we implemented a nitrate shunt in the mainstream. In 2016, after around 1 year of operation of the new part of the plant, the specific energy consumption for N removal dropped dramatically, as you can see on this graph. And yeah, as I said, the hypothesis is that we made a nitrate shunt with the Animox bacteria. But we haven't been able to prove that yet, but we are still working on that. So with numbers from 2005 to 2016, it is seen that we have reduced the power consumption of the plant dramatically, even though that we actually implemented new technologies on the plant. So in Aarhus, we think circular economy into the daily work, and this has resulted in us using the wastewater to produce energy from wastewater sludge. We produce heat and electricity, and the excess sludge is used as fertilizer on farmlands. So the best way to use the biogas in the best way, we implemented some new gas engines. so that we could utilize all of the gas that we produced. And also we implemented activated carbon columns for gas treatment, and this ensured that all the produced gas can be converted into energy and that the gas engines has longer lifetime as the gas is treated before entering the engine. And here you also see pictures of the gas engine installation and the gas treatment. But we are not finished with the development, and the newest action in 2018 is to construct a Phytorid production plant. And Phytorid is a problem on many wastewater treatment plants, and it deposits in pumps and pipes, as you can see on the upper picture, and it's causing major operations issue. The Phytorid contains phosphorus, and since it's a limited resource, it's important to investigate the possibilities for phosphorus recovery. The purpose of this plant is to control where the Phytorid precipitates and use knowledge of the chemical processes to produce a high quality and clean fertilizer that can be used on farmlands. And here you see some pictures of the plant being constructed, and we put it in operation in the beginning of 2018, and we're still working on getting the best results from it. So I would like to thank you for your attention, and this was what we brought.
Thanks a lot, Mike, and very interesting, and one can see such a wastewater treatment plant as a whole world in itself, and so many different aspects that you have to look at, and especially now embedding these plants into the circular economy in a city is really another exciting ambition to follow, and I think Aarhus has gone good strides forward to make this happen. Just to inform you, we are approximately 50 minutes now over time. Just keep that in mind. This time will eventually have to be stolen from the time that we have allocated for questions and some discussion at the end. So please, to all speakers, watch your time while you are going along. With this, we want to move over from Europe to Asia, and more particularly to India. And we have Dr. Rakesh Kumar, who would like to tell us or talk about a new technology for wastewater treatment that the Institute has developed, and how it is also applied in different places. So, Dr. Kumar, welcome, and we are happy to listen to you.
Hi, good morning to all of you. It's an excellent presentation before I start, and I'm delighted to be part of this webinar. It's really nice. What I'll do is some of the experiments in our 5-7 years which we have done in India. I'll just take you through from my slides. The main thing which has happened in our country is that we have had centralized systems earlier, and almost 90% of sewage treatment plants across the country are centralized. And when about 5-7 years back, when they were evaluated, we found that most of them were not functioning to the level desired. And one of the major reasons was that trained manpower to run all these sewage treatment plants were not available. And the second important issue was that the outlet of the sewage treatment plant, so-called treated wastewater, was not going for any reuse, so people actually neglected it. And the reason why I keep saying that sometimes centralized solutions will not work depending upon which country, which place, if we don't link to the circular way of using it. And I think that comment which was given earlier is very valid, that we need to bring in focus that finally the water which is generated should get used. Just to give you a sense of, if you look at some numbers, India generates about 68,000 million liters per day of wastewater from class 1 and class 2 cities. And when I say class 1 and class 2, meaning all those cities which are having population more than 1 million and 10 million. So class 1s are 10 million and class 2 cities are 1 million population. If you just look at the state of Maharashtra, where our institute is situated, that generates about 7,000 million liters per day. It does not include any rural area, and only about 30% of this gets treated in overall system. So when we start looking at these treatment processes, we had this question, why is it not getting treated? And another reason which came out very clearly is that many areas of India do not get 24/7 power supply. So some of the mechanized systems actually fail when we don't have power for 2 hours or 4 hours during 24 hours period. So that was one of the challenge, and that's why we started working on a technology. Can I have next slide? So we looked at how nature-based treatment can be used, and many of you would be aware that constructed wetlands have been used for stormwater cleanup in a large scale, many countries. But we looked at can we use this in a very engineered way for sewage treatment, completely. And the whole idea of doing this was that if we do it in a decentralized fashion, smaller region, I can actually use the treated wastewater then and there. And we called it, this technology was called Phytorid, because phyto means plants and rid meaning getting rid of pollutants, basically. So next slide, if I can. So if you see the schematic here, it actually is a combination of what we traditionally used to do, that we would have a septic tank. So we have actually redesigned the septic tank in a sedimentation tank, which is an anaerobic sedimentation processes. And the second tank, which you see, which is filled with the gravel, we call it Phytorid bed with media. It has a separate hydraulic system, so that the water actually moves up and down in a horizontal and vertical manner. And then at the top of the layer, we have wetland plants which normally survive throughout the year on the surface. So when all solids are taken care of in sedimentation tank, only the liquid part of it goes to this Phytorid bed. And here we see very distinct removal of BOD, COD, nitrogen, and phosphorus. And it's a combination of horizontal and vertical wetlands, which has not been done in the past. People normally do one at a time and then the other one later on. But we have been able to combine these two things together. The two novelty for which it was given a patent, one is that normally all wetlands-based treatment systems use soil for the beds for the plants to grow on the bed. In this case, we just use gravel, which is stone pieces, and so we treat the plant's root system in a way that they survive on the gravel. That was one. And the second one is most of the wetlands across the world have faced problem of flooding. The moment you have biofilm formation and if soil is there, of course, the movement of water is stopped or limited. So we have been able to solve that problem of hydraulic. So some of these plants which have been even commissioned 6-7 years back, they're operating without any operation maintenance cost. And as you can see, the whole flow is by gravity. So there is no pumping, there is no chemical which is being used. And at the end of it, when it comes out from Phytorid bed, the last tank is collection tank. And that's where we can choose if we want to do disinfection for some purposes, if I want to use it for agriculture or for flushing or anything like that. In case if I want to use it for a purpose which is for non-human contact, we need not do disinfection, and that's how it goes. So now we can move to the next slide. This is slightly, I would say, pictorial presentation of the whole thing. So as you can see at the bottom, we have bigger gravels which are between 6 to 8 inches. In the medium portion, we have about 3 to 4 inches. And the upper region is about 1/2 to 1 inch of thing. That's where the plant roots are. And these plants are such that they actually use their erythema as part of the plant, which actually releases oxygen in the bed. So the whole oxygenation process happens through the plant systems. So we look at BOD getting removed through microbial degradation, which is aerobic and anaerobic. The bottom portion is anaerobic and the upper portion is aerobic. Nitrogen is because homonification takes place, and phosphorus due to media absorption and as well as plant uptake, which happens. We also see almost 95 to 99% of pathogens removal, but it doesn't completely get removed after the Phytorid repair. So we have to essentially do disinfection at the end. Next slide, please. So when we look at this technology properly, we have an institution in our country. It's called Central Public Health Environment Engineering Organization. And this is the organization which actually makes manual to adopt technologies. So we have been able to demonstrate in recent past many of these technologies, and now they have got listed. As you can see, since we are not using any chemicals or any moving mechanical equipment, therefore the energy cost is very, very low. In some places, we may have to pump if the gradient of the place is not very good. So that's only the pumping cost, and that's what that is taken care of. As you can see, we have a major issues of in this kind of tropical country, mosquito nuisance, the odor. All of that actually gets taken care of once we use this technology. When we did this analysis of various technology on least cost basis, MBBR, activated sludge process, or for example, even membrane bioreactor, this comes out to be the cheapest option that we see right now in the country. Next slide, please. So if you look at some of these pictures which have been where it has been implemented, so colonies and apartments, hotels, many hotels and resorts are putting together. And what it also does, it gives a good landscape in and around the building and the place. This wastewater after treatment can be, after disinfection, can be very easily used for toilet flushing. And if you don't want to use it, it can possibly be kept in a water body, and one can do aeration, so that it's created a water body in and around. It's important to notice that in India we have a rainy season which is just spread over about 3 months. Rest of the period is actually dry period, and therefore water is scarce most part of the country, and any water that comes in can actually be important for all of us. So we have started using this treated wastewater to do some lake rejuvenation project. I'll show a picture as we go ahead. As you can see, the picture down below in the beaker, we get water as clear as normal drinking water. Of course, it's not fit for drinking. Next one. If you look at treatment efficiencies, we get suspended solids up to 95% removal, BOD up to 80 to 95%, COD up to about 95%. And it's very important that normal conventional sewage treatment plants, activated sludge treatment plants, do not normally remove nitrogen and phosphorus, which actually happens in this case. And some pathogens also get removed. Can I have the next slide? So this is one of the biggest, I would say, sewage treatment plant which has been built in East Delhi, where there was a lake called Swachha Lake, which used to have an area of about 35 acres, and where the water used to be there perennially throughout the year. But due to scanty rains and the way water bodies are not being treated very well, it became dry, and there was no water to get into the lake. So what we did, we got a drain which was just close by, and we picked up 3 million liters per day of sewage, and we are treating using this technology, and same water is being used to revive the lake. So now the lake has perennially continuous water available. Can I have the next slide? So if you can see some of these places where it has been implemented, and all of these places is actually being used for gardening purposes and toilet flushing purposes after disinfection. The contaminants level that, as I explained earlier, is just right for reuse for specific purposes. It can't possibly be used for any drinking water sources or anything else. So when we look at water, wastewater which gets generated from households or anywhere else, it has about 2% contaminants, and rest of it is actually water. So in place of doing rainwater harvesting, which is a common buzzword in our country, we have been saying that let's do water harvesting. The source could be any place, and we could start taking water out of it and bring it to the use. And the moment use is there, there is a chance that all the sewage treatment plants which have been in poor shape earlier, they will be maintained, and also maintained because the cost of the treatment is much lower than any other treatment plant schemes. The next slide, please. This is where it ends, and as you can see in the previous slides I showed you, it has been implemented in resorts, buildings, everywhere else, and we are looking at automating this whole process as we go ahead. The cost of treatment is almost 1/10 of conventional treatment plants, and therefore as a decentralized option, this is appearing to be one of the good choice to get implemented across country. Still, it's not something which has penetrated across, but it's taking shape, and probably in a few years people will opt more and more of this technology. Thank you.
Thank you, Dr. Kumar. It's really amazing what nature can do for us if we understand it well, and it seems like a really very useful solution, especially for an Indian context or for countries that are in similar conditions. It's great to hear from that. Now, we have really got very rich information with a lot of technical details too, and there might be a number of questions already lined up, and I think there are. So maybe we take a moment to respond to these questions before we forget too much what has been said before. There might also be questions that are relating to the larger context of wastewater management, the linkages to SDGs, to the urban agenda, and so on. So yeah, feel free really to put your questions into the chat form. I'm handing over to Serene to see or let us know what is there already.
All right, thank you, Barbara. So we already have a couple of questions for our speakers. The first one is directed at Ita and Maiken, and I think Rakesh can also contribute. And it says, you mentioned the centralized strategy for wastewater treatment in Aarhus. The question is regarding the adoption of such a strategy in India. Do you think here a combination of centralized and decentralized will be a better strategy for treatment? So please feel free to answer the question.
As I mentioned, hello, it's Gitte talking here. As I mentioned, there is about 25% of the total municipal area which has public sewage systems. And actually, it's this 25% of the municipality where we have our big treatment plants and our centralization strategy. We also have a lot of urban areas, and there we have more local solutions. So actually, we also have a mix of a centralized sewage plants for the urban areas, and decentralized plants for central plants for the urban area, yes, and decentralized plants for the suburban areas. So I think when you are asking for India, it could be a good strategy also there to have both.
If I can just add here, building on what you just said, India has been having mostly centralized treatment plants, and the experiences have been that they are so large enough that if for any reason it malfunctions, and one of the reasons which I mentioned earlier, that if we don't have power, which is 24/7, or we don't have a trained manpower, depending upon what the situation is, then after the malfunctioning, to bring it back to working, it takes minimum about 3 to 15 days, 20 days. So the wastewater which is coming during this period, has to be thrown into water bodies, and which are much more harmful. So the philosophy is here that if we have more decentralized plans, in place of one, if I have 20, maybe 2 of them could be non-functional, which can be bypassed to the other 18 functional systems, and we would have 100% of wastewater getting treated all the time, 24/7, 365 days. And I think that's the view which is becoming a little more robust in our country. But still, I would say most of the plants are centralized type which we have right now.
Thank you very much, both of you, for your answers. We actually have a lot of questions, so I'll see how many more we can take. And I will either take them later or you can write the presenters. So a question to you, Claudia, is the following. It says grey water will be how much economically viable for retrofitting in buildings?
Is the question in the chat here?
It was sent to me privately, so maybe...
Privately. So what does it mean, retrofitting? You mean retrofit? If there is already construction and then separating, retrofitting afterwards, the separation system between grey water and black water. Yeah, that's quite costly usually. It's much better, of course, to separate in the planning phase already, to plan already separated grey water collection and black water collection. Was that the question?
I'm not sure, so maybe if you're listening to us, whoever sent the question, it says climate expert, maybe you can send us a message and elaborate, or send Claudia directly a message with your question.
Yeah.
That would then be better. We have 3 more questions. I'll take one more, and then the others we can keep for later. And that is actually for Maiken. So it asks, have you already identified a solution for struvite recovery?
Yes. So we try to construct the plant, or we already have constructed actually the biggest phosphorus recovery plant in the north. But it's a very big plant, and it has influences on the rest of the processes in the treatment plant. So there's like a long commissioning phase, but we are already working on it, and it's going very well, I think.
All right, thank you very much, Maiken. And if the person who posed the questions needs further clarification, please feel free to contact Maiken directly. I think we will move on to the last presentation so that we can have more time for questions later. Togo, the floor is yours.
Hello, can everyone hear me?
Yes, perfectly, Togo.
Okay, fantastic. Good evening, good morning, and good afternoon. My name is Togo, and I'm talking from Tokyo. And today I would like to introduce you the wastewater sector and what's happening in Japan. So I'll give you the first slide, which is on introducing you the general information and challenge that we are facing in Japan. First of all, in terms of urban environmental infrastructure, this is the statistics that for your reference, and you would pretty much understand where we are in terms of this infrastructure development. For wastewater treated population, it's reaching up to the 90.9% of the population, total population, wastewater has been treated. And since we were talking about decentralized and decentralized, just to give you the detailed information, out of the 90.9%, the centralized treatment plant is around 78.8%, and decentralized is around 9.2%. So pretty much most of the facility is centralized wastewater system that we have. And others are community plants and also agricultural village treatment facilities, and in total that becomes 90.9%. The next plot is on waste, solid waste. I apologize, I should have written here not municipal waste, but actual total waste generated per capita in Japan. And this is 925 gram per capita per day. And the graph on the left-hand bottom is a graph taken from OECD. And this is the graph on municipal waste. In the case of Japan, the municipal waste is around below 350 grams per capita per day. And this has been decreasing over the years with the promotion of the government of circular economy, resource efficiency, such and such. Also, in terms of pipe water supply connection ratio, this is the graph on the right bottom side. We have around 97.9% of the population covered. And this is pipe water supply. So others are usually connected through the, for example, groundwater, the well water, such and such. The next slide, this explains about where we are in terms of population demographic. This is very significant in the case of Japan, and I'm sure that this is the same in some of the Asian countries. And I would like to introduce you this slide particularly because I think this is something that most of the countries will face in the near future. This will give you some picture of where, for you to understand where we are in Japan. The graph on the left-hand side, this graph was produced at 2014. Sorry that this is in Japanese, but this literally just shows that our projection of population leading up to 2050. And the green part is where we have population living at the moment, but we will expect that there will be no people living because of population decrease in 2050. Now, dark blue part is where we expect over 75% to 100% of population decrease. Blue is where 50% to 75% of population decrease is foreseen, and light blue is 25% to 50% decrease. And the yellow part is where 0% or 25% decrease, and the red part is where we are expected to see population increase. Now, I think you could pretty much imagine what kind of magnitude this will have in terms of political significance and economic significance, and that the impact to the local governments in Japan. And the right-hand side graph shows our population from the past history from 800 and to the projection to leading to 2100. In Japan, our national population peaked at 2008 at 128 million. But then in 2050, we expect to see a decline to 95 million. And you can see that in our modern history, we've never experienced a case where we have to deal with the population decreasing cities or population decreasing society. And the speed in which the decrease is happening is very steep and very fast. So this is something that has been drawing a lot of, discussions and a lot of arguments at the local and also at the national level. When we talk about pretty much everything really about economy or the infrastructure and how we sustain this environment on such and such. So this is the general context that that the Japanese local governments are facing. So what the local governments are expected to do is to maintain the high standard of urban environmental services, as I just explained in the previous slide, while experiencing population decrease and aging society. So this is the challenge. With this general information, the national government came up with the 5th Basic Environmental Plan last year in April. And this plan is usually revised around every 6 years. And in this Basic Environmental Plan, they came up with the concept called Regional Circular and Ecological Sphere. Basically, what this means is that it's clarifying the importance of promoting carbon and resource circulation on optimal scales, according to the characteristic of the regions concerned and the nature of resource to be recycled. So it's a very simple concept, but basically, whatever resource suitable for circulation in a small area should be circulated in the smallest zone possible. And whatever the resource suitable for circulation in a larger area, it should be expanded. It should be circulated in an expanded area. And with this concept, we are trying to achieve a society where we have energy circulation, material circulation, and a society which has balancing and living in harmony with nature. So this has been, promoted or promoted by the central government to be, utilized or to be a guiding principle for any kind of planning that will happen from now on. And to give you one of the example of such concept putting into practice, this is one of the example. So basically, I've mentioned that the population is decreasing, and the fact that we do have a relatively good record of coverage area of wastewater treatment. So when we have a population decrease as a condition that is putting on top of that, we are actually seeing, the spare capacity of wastewater treatment facilities. Usually and I presume that most of the cities that are experiencing population increase is all about trying to find a space for wastewater treatment facility to be built. Now, when we have population decrease, then we have now spare capacity. So what the central government is promoting is to actually changing these wastewater facilities to more of a energy and fertilizer production facility. So how do they do that? It is pretty simple. You have existing wastewater treatment plant, but then you inject or you collect local biomass, such as trimmed branches, organic waste, night soil, or livestock manure. You inject that into the existing treatment plant. You, of course, need to invest a little bit more, but then you produce biogas. You use producing phosphorus and selling that to fertilizer company, and then also you produce solid fuel such and such. And this kind of facility, we have a number of examples around Japan. And one of the examples I just showed here is at the city called Toyohashi in Aichi, where they conduct this as a PFI project. And literally, they just collect sludge and night soil and waste, organic waste. And then they make methane fermentation, power generation, and carbonization. And then they produce electricity in solar fuel, such and such. So this is maybe one example of adjusting the existing infrastructure to accommodate the demographic change that Japanese cities are experiencing at the moment. So this is rather more of a facility-based information to all of you. But then, as introduced, I would like to share with you some of the activities in Japan on obtaining public support. Now, I think all of you who are participating today would understand that the wastewater management is a highly costly infrastructure, and I mean, there's a statistics, that shows that it's actually 3 times more costly than water supply, such and such. And we all understand that once this wastewater treatment plant is made or developed, it all goes underground and it becomes invisible. So, and of course, it's very difficult to obtain public support when the facility is invisible. People do tend to forget that what they're benefiting from it. So the public PR, public relations for the wastewater treatment plant or facility becomes extremely important to continue having government subsidy to flow into this sector. Otherwise, maintaining the infrastructure is extremely difficult. So from that perspective, a lot of local government in Japan uses their imagination to actually create and to obtain public support. And I'm just introducing you some of the example. And the one that I'm showing right in front of you now is example from Yokohama City, and where they produce a walking map. And basically, they connect wastewater-related facilities across the city with pathways, and it's following the water flow. And what that exactly is in the second next slide. So, of course, in Japan we have a lot of a culture of animation and all that. So, actually, we have the Yokohama City have a character which is based on hippo. And as you may know, hippo lives in a very clear water, right? And so this hippo is actually used to actually draw interest from children, and to deliver message something is rather associated with dirtiness or something not clean. But then by using this animation, it's much easier to communicate with children or with public. So the character in this case is used for that purpose, and it's not only used for this this pamphlet as such, but this character appears every now and then when they conduct a public seminar, for example, to draw people. And just one example of this pathways, they introduce the major facilities related to drainage and wastewater management. And some of the example is introducing public information center and the nature parks that you could go through. And then the point is that they say that this is all possible because we have wastewater facility that is functioning properly. And in addition, there's information about underground water reservoir for drainage. So this, of course, we sometimes open these underground water reservoir for public in some cases, but this is also one of the good example in infrastructure where usually it's always unnoticed, but it's very important that the local people know about this facility, that costs a lot, but then it is protecting their lives. So they're using this pamphlet to also introduce this. And also to your right-hand side, this is the a kind of like a facility that we have all around Japan, which is the emergency toilet facility. And it's really interesting because I think this is part of the pamphlet, and it actually explains to the general public how to set up this emergency toilet. Of course, you don't expect like normal people to set up during the emergency. But then the purpose is to make people understand what kind of facility this is and why the local government is investing on such infrastructure. And the best way to explain is to explain the function. And so they use animation to deliver the message saying, okay, step 1, you do this. Step 2, you have to fill in the water first, and then step 3, such and such. Now, these detailed information does help people to deepen their understanding on infrastructure, and their appreciation, and thus also contributing to increasing the resilience of the city itself. You would be quite surprised, I think, because a lot of Japanese population have a very good understanding of infrastructure, and it's coming from this kind of local government activity on PR. One other example is the one that was introduced, and this is quite unique, I guess. It's a manhole card that is being produced. Now, you may know, I mean, a lot of I think a lot of people know about sports card, where you have your favorite players, and in the kids, they collect the card and they, somehow exchange the card with your friends and such. Basically, it's the same similar concept. Now, traditionally in Japan, local governments tend to use their own local culture reflected into the design of their manhole. Now, please don't make a misunderstand that not all manhole is colored, as you can see on this card. Most of them are not colored, but then design is there. Now, you can see many kind of design, like with the Japanese castle and, of course, Mount Fuji, and with Hello Kitty animation and the dinosaurs and all that. And in order to, increase the publicity, what they did was they've called upon the local governments to apply to be part of this program. And the local government pays for just printing and all that. But then basically, what happened is that this card is produced. It's not sold. But then if you want to obtain this card, you have to go to a particular place. And that particular place is usually a wastewater treatment plant or related facilities. And they have like 5,000 cards available, and they announce it on the internet, and people go and actually to those facilities to collect them. And there's total 478 cards now, where we have around 407 local governments participating. Now, this is quite an interesting way to make people look down into the facility. And what the government and the sector is trying to do is using this as an opening, entry point for those people who usually do not have any interest in, wastewater, to be interested. Literally, people are, if they want to collect this, they will have to go to this facility on foot or whatever, and then literally they are kind of forced to understand and see the facility by themselves. And by putting it in the form of card, it actually makes people to feel that they want to collect them all, and basically that's happening. And so when the local government also, when they do the, public participating seminars, for example, on related to sewage or something like that, they also announce that, okay, if you come, we will hand out this card at the end of the seminar. And then this is kind of like one way of drawing people's interest to participate in the seminar. Yes, this is for your information. And also, one of the I mentioned that the government has been promoting to produce fertilizer and energy such and such through wastewater treatment plant, and one of the ways of using the resource being collected is on agriculture. Now, of course, it is a challenging sector because, of course, when people say, okay, we use this fertilizer for agriculture product, it's very difficult to obtain support from people because, literally that's, it's negative, negatively, how do I say, preserved. But by conducting public relations and making people understand what that is in an open manner, then you will be able to obtain support from people. And this is the case in Japan now. Of course, there's still a lot of challenge that needs to be addressed, but by these activities, there's a lot of expansion of using the fertilizer or resource collected through wastewater management into agricultural product as well. Just to share what this is, the brown circled or squared product is produced from fertilizer that has been extracted from sludge. The blue squared vegetables or the pictures are using treated wastewater. And then the pink one is actually using the heat and carbon dioxide generated from wastewater facilities for the agricultural production. So I think our experience that we're having in Japan is that although these kind of activities is rather time consuming and rather difficult, but once you have a certain amount of population understanding the facility and understanding in a scientific manner, then it also opens up potential to further utilize the resource generated from wastewater, which is usually associated with dirtiness or something like that. That's all for me. Thank you.
Great, thank you, Togo. I, again, learned a lot of new things, and I feel like I want to buy a ticket to Japan to come to you and see all these things myself as soon as possible. It's really nice to see these different perspectives also on how, and making a point about people knowing about the infrastructure and what is happening underneath their feet. And, to have so nice ways of doing that, really interesting. So we have actually already reached the end of our webinar in terms of time, but there are a few questions waiting to be answered. And it would be great if at least our speakers could hang on maybe 5 more minutes to look at these questions and respond to them, because it would be a shame to ignore them now. So let me also remind you that the webinar is obviously recorded, so for those who really have to leave, of course you can always leave it now. But it would be great if our speakers stick with us for another few minutes. So I would hand over to Serene to just look at these questions and share them with you.
All right, thank you, Barbara. So we have a number of questions. I think due to time, we'll restrict them to 2 questions. The first one goes to you, Claudia, and it says, do you see the Hamburg-Jenfeld project as future trend in Germany?
Oh, thank you very much for the question. Very good question. Unfortunately, there's mostly in whole Germany, there is already the centralized system implemented, and that's why it's very costly to retrofit. So yeah, it's not really a trend for Germany. It's more, I see it more as a demonstration for other countries that are in place, that are in the phase of planning a new wastewater treatment system, and they want to look at other options instead of sort of traditional combined wastewater treatment, collection and treatment and activated sludge system. Thanks.
All right, thank you very much, Claudia. The second question is actually for all the panelists, and it says, thank you for the webinar. This is Utkar Setia from Development Alternatives India. And it says, kindly provide your view in integrating the centralized and decentralized wastewater treatment technology in series for achieving good quality wastewater for agriculture use. food crops, for example, for a small farm for which the treatment of all the wastewater from centralized system is not needed, but a little amount from decentralized system only. Is the question clear? If anyone wants to answer, please go ahead from our panelists. Should I repeat it again, just for clarity?
I think that's a good question for
Rakesh, I
from
think,
India.
yes.
So I think the system that he presented is very useful.
Yes, Rakesh, would you like to answer the question?
Trying to respond to this. What happens is when we have centralized treatment plant, they are in terms of volume and flow that it deals with is very high. And if you want to take all of that water for reuse, the cost becomes too high. So what is better to do is take a small flow and take it through one level treatment mode. It could be tertiary treatment like sand filtration, activated carbon, or depending upon what reuse you want to do it, we can add that and then take it for reuse. So what happens is we could do centralized system also combined with some decentralized system for polish the system, and then reuse wherever it is required. Only point is the reuse location should be very close to the place where the centralized system is located. Otherwise, the cost of transporting all that treated water itself can become a major task. Thank you.
All right, thank you.
May I also respond?
Yes, of course.
In the case of Japan, I think it's all about economy and how it could be financed. And so you have to take it into account the geographic condition as well as population density. And then my advice to you is the demographic changes that you might see in the future, which is something that has been not particularly being addressed properly in the case of Japan. So everything was equipped for population increase, but then now we are seeing population decrease. So that does also happen, and I think that's the combination. And sorry, additionally, availability of land also, of course. But these are some of the preconditions that you will consider, and then literally you just consider what facility is more suitable to deliver the service. Thank you.
Thank you very much, Togo and everyone. And actually, there's a comment here from Claudia who says that thank you for your presentation because Germany is currently also facing the same demographic changes as in Japan. And I think that's the case for a lot of countries in Europe. So it's quite forward thinking, I think, from your end. Maybe the very final question goes to Rakesh, and I think we can end with that one. It says, my question is regarding the use of the treated wastewater for agricultural purposes, and then asks, kindly provide your views on the same, especially taking into consideration that treated wastewater might contain contaminants. Rakesh, would you like to take that question?
Yeah, just one second. I was trying to read the question that was there. In fact, it's not very clear what kind of contaminants that we're talking about. When we look at sewage as such, if it is not mixed with industrial effluent, it has very limited contaminants, and which we know. So after the treatment from centralized or decentralized plant, what you have is microbial contamination, and that's the one which can go away after disinfection. So we could deploy any of those, and then it can be used very safely for agriculture.
All right, thank you very much. We don't really have time for any more questions, so I'll hand back to Barbara to wrap up the webinar. Thank you all very much.
Thank you.
Yeah, grateful for this conversation also, and thank you to the participants that have contributed with their interest and their questions. I think we've really covered a lot of different aspects in wastewater management, and it's amazing how such a rather, say, dirty and smelly, topic can still lead to such a refreshing discussion. And yeah, there are lots of options and new options to deal with wastewater, and a lot of further research is also going on worldwide. So, and it's great also to see how much wastewater can contribute to what we all want to achieve, namely the circular economy and circular cities. So thank you once again. That's really great, and I hope you enjoy the rest of your day or afternoon or evening. Goodbye to everyone, and a final big thank you. Bye-bye.
Bye. Thank you.